what I'm asking you to do with this focus, we're going to review Tuesday's material. What we need to do to create these sketches is we need to find the x-intercepts. We need to determine the end behavior. And then we need to create the signs table to determine if the graph is either going to be above the x-axis or below the x-axis between those zeros. Okay, what I had listed in those notes. So with a few of these, we're going to have to do a little bit of factoring. These ones right here are already factored, meaning that I should be able to find the x-intercepts pretty easy. These two up here, we're going to need to factor these. And eventually we're going to end up with all of these things multiplied out, even the bigger ones that have powers bigger than squared. And we're going to find all those zeros so we can initially make these sketches, okay? So let's talk about the factoring right here. So if we look at number 1, we have x squared minus 4. Now there is a special rule for this. It's called the difference of squares. We did this in Math 3. And the reason this is called the difference of squares is we're subtracting two terms, and both terms you can take the square root of. What that means is this is going to factor in to two monomials. One of them is going to be minusing these terms, one of them is going to be adding. And what we do is we take the square root of each part. And this only works when we only have two parts with a subtraction between them. And you need to get perfect squares, meaning what's the square root of x squared? That's x. So the first part of this is going to be x. Second part I need to look at is what's the square root of 4? Square root of 4 is 2. So that means this part is 2 and this part is 2. So x squared minus 4 factors into x minus 2x plus 2. Now just on a side note, say that you were to forget that. This factors just like every other one that we factored before, every quadratic. This is x squared minus 0x minus 4, meaning you could draw the box and factor this if you were to forget that rule. This is still x squared, this is still minus 4, but what we're looking for, we want the factors of 4 that subtract to give us 0. Well, that's 2 minus 2, so this is negative 2x and positive 2x, and then we can factor it using the box the exact same way. All difference of squares you can still factor in a box. So if you were to for some reason forget that rule, you could still draw a box, put a 0 in the middle, 0x, and you could factor it. This is going to give me the x minus 2, this is going to give me the x plus 2. Okay, so all of these are still box factorable. If we look at number 2 before we move on, so we can write it there, we get negative x squared plus 25. And we have an initial want to, hey, that's the difference of squares. But is that really the difference of squares? It's not the difference of squares yet because those two things are adding. But we also have this weird negative out front. Now this is really a 1. We can factor that negative 1 out of both of those, and now that becomes the difference of squares again. Now we can factor this into the two parts. We just have this negative out front that we didn't have before. So this becomes x minus 5, x plus 5. And then we're going to use that to find our x-intercepts so we can list them, okay? So right now, I'm not going to give you anything that you can't factor with tools you already have, meaning it'll be quadratic or they'll have some common factor in them, like a common factor of x that'll bring it down to a quadratic so you can factor it. Eventually, we'll get to ones where we can factor everything, but we're just not there yet. So let's write this factored form in here on number 1. And then we will go through, we'll find these x-intercepts, we'll talk about end behavior, and we'll make our charts. You guys ready? Let's do it. Okay. So first off, let's talk end behavior, because you got to remember our overall goal is we want to make a sketch. But really, I know you probably know what x squared minus 4 looks like, because it's an x squared that's been shifted down 4. But I want to practice with that the information shows you what you expect to see, okay? So that you know that when we do these bigger ones at the end, we're really finding what it looks like, even though I can't predict exactly what it's going to look like. So let's talk end behavior. So what is the leading term of this? Leading term is x squared, right? And there's two things that I care about. I want to look at the coefficient, and I want to know whether it's positive or negative. So the coefficient, the number that's up here, what number should be written there? Should be a positive 1. So 1 is positive. Then I want to look at the degree that it shows me. The degree comes from the exponent. So that means this is a second degree polynomial. These two things together will tell me which way the ends of my graph should point. Now this is a parabola that's been shifted down. Which way do we expect them to point? We expect them both to point upward forever. But if we come back here, we have ours is an even degree with a positive, so it tells me that those ends should point upward exactly like I expect. What I'm trying to do is justify is that this chart, even for these really big polynomials, will work the same way. It'll tell us which way the ends are supposed to point. So based on all our information so far, and you can write it like this. The ends of this graph should point up and up. That also means that the y values that we should find should be positive and positive at the end. Even though we're going to test these things in the sign chart table, it's good to have this written down because you can check your positive and negatives to make sure you've done this right. So this is how we determine, and what we found here is this is the end behavior. Now the other thing we need to find before we jump into making the sign table, we need to find the zeros of this. What else are zeros called? They're also called x-intercepts, okay? The reason we call them zeros is because it describes what you would do to find them. Now we factored this on the other side. We know this is x plus 2 and x minus 2. If we set that expression equal to 0, it will tell us where this graph crosses the x-axis, because what we've just done is we've made y equal to 0. To be on the x-axis, you have to have a y of 0. So this will solve into, this is x plus 2 equals 0, which means this one is at negative 2. This one is at positive 2. So let's actually put that on our graph, kind of like I did in that example on the Canvas page. We know that our graph crosses here and here. Which way do we know the ends go? Based on this, we know the ends go up. Now what we need to figure out is, we need to be sure, we think that it should be negative, but we need to create the sign chart to make sure we've got everything, all the graph parts in the right spot of the y. Meaning we need to figure out whether the y values are going to be positive or negative. Now the way you set the chart up, to make it a little bit less table-y like it was in that big example, I'm going to put two things right here. These are my x-intercepts. So one of them is at negative 2, and the other one is at positive 2. I'm just trying to give you something that might be a little bit easier to see on your paper. Now we need to pick some test values. The values you want to test need to be, this is like the number line. It's not like the number line, it is the number line. We need to pick numbers to the left of negative 2. So when you go left, that's more negative. So things like negative 3, negative 4, negative 5. You could test any one of those. I always suggest to Don't test like negative 102 because it might get tough when you do the subtraction in your head. So let's say we're going to test negative 4 out here. Somebody tell me a number between negative 2 and positive 2. 0. I like 0. 0 is nice because it's easy to see. And then now we need something to the right of positive 2. The right of positive 2 is, let's use 5 because I do want to emphasize that I just need to pick something bigger than that. Now what I need to list here is I need to list the sign of each one of these things like I plugged that number in. So for example, I want to take this negative 4 and put it in here and here. And the only thing I care about is that I want to know if the result is going to be positive or negative. Because this is this end, we suspect that we should get a positive. But let's be sure by plugging in. So negative 4 plus 2 is a negative number. Negative 4 minus 2, is that negative or positive? Negative 2 minus 2 more, that's also negative. And then a negative times a negative overall is a positive. Now, what does that positive mean? That positive means that our graph is going to be above the x-axis. Plug in the 0. We're going to get a positive out of the first one, a negative out of the second one. That gives me an overall negative, meaning my graph should be below the x-axis. We do the same thing with the 5. 5 plus 2 is definitely positive. 5 minus 2 is also positive. It gives me an overall positive. And that positive tells me my graph should be above the x-axis there, which is what my end behavior did. So the only thing I need to finish filling in is what I had here. So technically I asked you to sketch them, this is the answer for this, for the focus, but the information is the important part of this because this is the stuff that we're going to need to know how to use when we get to the bigger ones. One quick thing about my sketch. Which axis did I not put any numbers on? I didn't put a single thing on the y-axis, which is I did a really bad job of highlighting it. Reason I didn't do that is because we could find that y-intercept for this one because it's easy. Normally, we want to do these sketches without calculators because you just want to get an overall general feel of where the parabola is going to go based on the information. Y-intercepts can get really, really, really big. And I don't want you trying to calculate really, really big numbers in your head. So I just kind of leave them out. The important part of this is whether it's above or below the axis in between the intercepts, okay? Let's try the second one, see how we do. So we already factored this. This was negative x minus 5, x plus 5. Now I'll multiply it out. We talk about the lead coefficient, or the lead term, right? So the leading term is negative x squared. So the number in front is negative, and the degree is a second. So that's a even number. So we have negative and even to go back and check on our chart. So let's go back and see what that is. So we don't have positive this time, we have negative. We're also even, so that means that these things are going to point, they should point down this time. And that's what the table tells us. It gives us two of our zones so we know where we're going to start with our sign tables. So these two bits of information together tell me that the ends of the graph should point downward. Now we need to find x-intercept. So we're going to set this thing equal to 0. Now the only things that I can plug in 0 for are this one and this one. There's no way to make negative 1, 0. It doesn't affect the x-intercepts at all. So x minus 5 gives us this one is at 5. X plus 5 equal to 0 gives us that this one is at negative 5. So what we know so far about our graph, if we're going to make a sketch, it's got 2 points. And based on this information, we know that this should go downward, not with a curve. With a curve, not with a corner. Now let's complete our sign chart so that we can justify where the rest of it is. So we're going to start with our zeros, so negative 5 and positive 5. The reason I put boxes around them so I don't get them confused with the test points, because as this stretches out, we have more x-intercepts, it can get a little bit messy. To the left of negative 5, let's use negative 7. In between negative 5 and 5, I want to use a 0 again because that's easy. If I can use 0, I will. To the right, let's use 6 this time. As long as it's more than 5, it doesn't matter. So we're going to plug these into our equation to figure out the sign in each of them. Remember, we want to figure out the overall down here because that'll tell us where it's supposed to be. Now, we kind of already have bits and pieces of this. We just want to use the signs to check it. Based on what we found for end behavior, we know that this should be below. This should also be below. So we should get an overall sign of negative, and we're using the end behavior to tell us that. It's a good check to start with to actually still plug the number in because you can catch any errors you might make right in the beginning. So let's plug that in. So negative 7. What is negative 7 minus 5? Is it a positive number or a negative number? It's a negative number. And negative 7 plus 5 is a positive or a negative? It's a negative. So negative times a negative is a negative?
Positive.
That's a positive. Wait a minute. But our end behavior told us it should be a negative, right? We messed something up, didn't we? Do we forget anything that's written in the equation when it's factored? We forgot about that. What happens when you multiply anything by -1? It changes the signs, right? This one really has 3 signs that we have to deal with. When you get a negative that factors out like that, and I'm going to write this one in green when I get up here on the pen. This one right here needs to be included in each and every one of them. It's always going to be negative. There's a -1 floating out there. But we can't forget about it because it'll break our sign chart when we go through and do it. Because now, even though we only had 2 zeros, we have 3 factors because there was a negative number out front. Negative times a negative times a negative is a negative. That's also why I set this one up so we would see that, okay? Now let's plug in the 0. 0 minus, and notice that I wrote it in there for all of them. I did that in the beginning when I see that factored out so I don't forget about it, because it's really easy to forget about that as you work your way down. All right, let's plug the 0 in. 0 minus 5 is negative. 0 plus 5 is positive. So is that overall going to be positive or negative? Positive. That means that this part should be above, which makes the parabola that's been flipped and moved up. And it makes sense. 6 minus 5 is a positive number. 6 plus 5 is positive. And now we get the positive times positive is a positive times a negative. Now, one little trick that I actually learned last year, something because I usually just think these things through in my head. Positive times negative. Any odd number of negative signs will always result in a negative. Any even number of negative signs will always result in a positive. Now, what I mean by that, I'm going to add into this. If you did your sign chart, let's not even worry about the numbers. We got a negative, 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 positive, negative, positive. That's a whole lot of multiplying to do in your head, right? How many negative signs do you have? You got 4. That's an even number. That means overall that thing is going to be positive. Whether this is positive or negative is completely dependent on how many negative results you get out of your plugging in, okay? So if negatives are even, you're going to get positive and above for your answer. If the negatives are odd, you're going to get negative or below. And I think that's an important kind of conclusion for this as we work through, okay? Now what I'd like you to do, I want you to try this one by yourself first. A pre-constructed part of this. I've left out the sign chart because I really think that's where most of our practice needs to fall. I did the lead term and I found the zeros. Now let's talk about the leading term for a minute. This has already been factored out, okay? Meaning I have 4 factors here. You can multiply that all together, right? You could draw 2 sets of boxes, find the answer, then draw a bigger box, multiply it all out. But what number do you actually need? You only need the leading one. I know that it's going to be negative x to the 4th. Why? How many x's are in this thing? There's 1, 2, 3, 4. Meaning the biggest power I could get is when I multiply all 4 of those things together. How do I know it's going to be negative? Because that negative right out front, okay? The end behavior becomes a little bit more challenging when it's given to you in factored form, because finding that lead term is tough. But you can still get there. There's 4 x's and a negative out front. That's how I got this negative x to the 4th, which is a negative and it's an even. Come back all the way to the front to our chart. Negative and even means that the end should point down again. Found all my zeros and put them on the x-axis, which it was already factored, so it was pretty easy. And that means this end should point down and this end should point down. What happens in here is what we need to figure out with this chart. Now, at this point, we probably suspect, because what we've seen is it's crossed every single time. It's not always going to cross. And one of the questions I have you answer in part of your work is, can you tell me by looking at the factored equations which ones cross and which ones don't? And we'll get there in a little bit. But let's actually go through and see if this one crosses the x-axis every time. So how many signs in our sign chart? We've got 4 zeros, but we also have the negative up front. So let's do that one first. If ever you have a number here, put that number in your sign chart first. Whether it's positive, it's going to be negative or it's going to be nothing. But let's put that negative on the top first before we worry about plugging in any numbers. It's going to exist in all of them. It's always going to be negative. There's no way it can change when we do that multiplication. Now we just need to take this number, our test value, and put it in each one of them. So we think, based on what we know, that we should get an overall negative, and this should be below, because that's what the end behavior told us. Same thing here. But it's always good to check the ones that you know to make sure that you have all of the right signs working in there. It'll help you discover some of the patterns. So let's put negative 4 in here. So negative 4 minus 4 is a negative number. Negative 4 plus 3 is a negative number. Negative 4 minus 2 is also a negative number. And negative 4 minus 6 is also a negative number. How many negatives do we have? We have 5. 5 is odd, right? If you have an odd number of negative signs when you do your chart, that means the overall is going to be negative. We did that one right. So that means at least what it tells you is as you go through, you plug this in, you have it all factored out. If you can match your end behavior one to your sign chart, hey, I'm doing this right. So that means if I continue the same process, I'm going to get the right answers as I work forward. So let's plug in 0. Negative, positive, negative, negative. How many negative signs? 4. 4 is even. So that means this is going to be positive, and the graph should be above, meaning that in here, it's going to be above. Now, I know that the line needs to be above the x-axis, and it needs to curve back down and hit that 0 right there again. As you go through, you can almost put each piece of this in as you fill in the sign chart. That was above, so that part of the line needs to be above the x-axis. We're going to plug in 3 now. 3 minus 4 is a negative number. 3 plus 3 is positive. 3 minus 2 is positive. And 3 minus 6 is negative. 3 negative signs means overall we're negative, and this is below. So between 2 and 4, our graph is below the x-axis. Let's fill the last one. Well, we got 2 more to fill in. Let's fill the last one that we don't know really already, and then we'll check the end. So we're going to plug the 5 in. 5 minus 4 is a positive number now, because that's 1. 5 plus 3 is positive. 5 minus 2 is positive. 5 minus 6, that's still negative. 2 negatives, that's even, so that's positive. That means our graph is going to be above. So between 4 and 6, we're going to draw our graph above the x-axis. Now we're pretty sure from this that this should be below and negative, but let's check it. So 8 minus 4 is positive, 8 plus 3 is positive, 8 minus 2 is positive, and 8 minus 6 is also positive. Down to 1 negative, so that means it is going to be negative and below. That one checked, just like that one did. And there's our sketch. I'm going to do one more, okay? These are the same 4 from the notes on Canvas, but I wanted to do them live. Let's do this one. This one's a little different, okay? And I want you to write the equation down right now, but we're going to do it together. We're going to find the lead term, find the coefficients and the zeros, and figure it out. So why this one is different? Tell me once you write the equation down and I'll switch it. Well, we can talk about it right here, and then I'm going to talk about what it means. What's different in the way the equation is listed for what we're doing right now to what we just did? What have I added to this? These parentheses now have powers. That's the only difference. So let's talk about what that means. What does it mean when I say x to the third? It means x times x times x, right? So what does x minus 1 to the third mean? It means x minus 1 times x minus 1 times x minus 1. It's a simplification to write this expression shorter, but we need to remember the power has that same meaning. Whatever's in here gets multiplied by itself that many times. So in reality, even though we're not going to rewrite it that way, how many times should I write this x plus 2? I should write it 3 times because it's got a power of 3. Same thing with this x plus 1. I should write it 4 times because it's got that power of 4. Now, how that affects our lead coefficient? Well, I know it's going to be negative because of the negative out front. How many x's do I have? Well, this one's really there 4 times, right? This one's really there 3 times. So that's 7 all by itself. These are only there 1 apiece. Those are really supposed to have 1s with them. We just don't write 1s. So it's really, when you talk about its degree, it's actually x to the 9th. Because when you get powers on these parentheses, that means they're in there more than once. If we wrote this all out, we would see that many x's in there. So we're really multiplying them that many times together. I just don't want you guys to spend the time to write out all those x's when you can look at the powers and find it. So let's see, this is, its coefficient is negative, and its degree is 9, which is odd. So this one's different than the other ones we've done. Now, anytime you get an odd one, it's going to point, it means the ends point in opposite directions. Evens always point in the same direction. Odds point in opposite directions. So let's scroll all the way back to our table in the front. So we're over here on odd, and we had negative. That means the left end will point upward, and the right end will point downward. Too far. So that means for our graph, we should see positive y values first, negative y values at the end. Let's list our zeros. And remember, that happens when we put this in with -1 here. We're going to put 0, this equal to 0. Don't forget the -1. Now, when you're finding zeros, the powers don't affect the 0, okay? That's why we can group it together. So this still tells me that it's going to have an x-intercept at -1. This still tells me this is going to have an x-intercept at +3, -4, and -2. So far, we know our graph. We know our graph has x-intercepts. We've got one at 3, -2, -4, and -1. And based on our end behavior stuff, which we'll double check when we get to the sign table, we are pretty sure that this, well, we know for a fact this end is going to go up and this end is going to go down. Now, there's only 2 options as it's in between. Well, you're either going to be above the y-axis or below the y-axis in those ranges. And you have 2 options at each x-intercept. You can touch the x-axis and bounce off of it, or you can go through it. And a lot of this is trying to discover why we're bouncing sometimes. And you'll see that in the end graphs and as you progress through some of your practice for today's work. So let's build our sign chart and see what happens. So let's see, we had -4, -2, -1, and 3. Those are the zeros that we found. And we're going to pick test values. So to the left of -4, let's use -5. In between -4 and -2, we'll use -3. Now this one might be a little trickier because in between -2 and -1 means we've got to pick a decimal. I've avoided doing that until now. Only do it when you have to. You could always test these with decimals, but that makes the work harder to do when you're looking at it. So only do decimals if you have to. I'm going to split it even. 1.5, okay? And then the test value in here, -1 to 3, I'm going to use 0, and let's use 6 right here, because anything bigger than 3 is going to work. So we're going to find all the signs and determine our above and below for this. Now, based on our end behavior stuff, we are pretty sure, well, we know that we should find this one to be positive overall because we know it's above the graph. So that means the sign chart should come out positive. This one should come out negative and tell us that it's below. They're kind of our checks because as we get to some of these tougher ones, you kind of need something easy to make sure you're doing the math right, okay? So this, again, has a negative symbol out front. So that means we're going to lead everything with a negative sign. There's our one not to forget about anytime we see that negative in front. Now we need to deal with these things with powers and stuff, okay? Because now we need to work with both of them. So let's talk the number first. So we're going to plug in -5. -5 plus 1. Is that a negative number or a positive number? But what about the power? So this one you might need to actually look at a calculator. Let's break this down because I'm doing this first one with this power of 4. So we have -5 plus 1 to the 4th. This is -4. But we need to take it to the 4th power. Now, I don't expect you to know 4 to the 4th power off the top of your head. But let's think about it this way. This is -1 times 4. And they both get taken to the 4th power. Do I care about what 4 to the 4th is? No, I don't care about the actual value. I only care about whether it's positive or negative, which is governed by this. What happens when you multiply -1 by itself 4 times? Is it positive or is it negative? It's positive because it's -1 times -1 times -1 times -1. That's positive 1. That's positive 1. Positive times a positive is a positive 1. So that, because of the 4, that makes this thing positive. Now, as we go through and we do this some more, does it matter ever what number I get inside here? What will it always be? Meaning, even if I got negative that, and I take it to the 4th power, is it going to be positive or negative? I take a negative number, I multiply by itself 4 times, it's always going to be positive. And since I don't care about what the actual value of that number is, I only care about its positivity or negativity. But what we're getting at is anything to the 4th power is always going to be positive. It works the same way. Remember this one? X squared. Does that ever give you a negative answer? Like, what's -3 squared? Positive 9. What's -4 squared? Negative times a negative gives you a positive. Any even power will always yield a positive answer. So because of that, it actually gives me a second one that I can fill in all the way down without ever doing the math. Doesn't matter what I plug into this, because it has a power of 4, its answer will always be positive. Every single time. So that power actually made the problem easier for the sign chart because I can fill it in all the way across because even powers always come out positive. Now the other 3 I do actually need to plug in and check because these still have odd powers, and odd powers are ones that can be either positive or negative. So it means I still need to actually plug this number in. So -5 minus 3 is negative. -5 plus 4 is negative. Now this one we need to think about, but here's what you need to remember. It's an odd power. It's going to come out as a negative number if there's a negative inside. If there's a positive inside, positive times itself 3 times is going to also be positive. So this one is defined by what happens inside this addition subtraction. So -5 plus 2 is negative. That power of 3 is not going to change that. The only one that got changed are even powers like this 4. It'll make everything that comes out of it a positive. So now if we look, we double check ourselves. We had 4 negative signs and we said that would have been above, so that one checked. Let's plug in our last few and, well, wait, that's above. We already have a graph. Plug in our last few test values and see where we go. So -3 minus 3 is a negative. -3 plus 4 is a positive. And -3 plus 2 is a negative. We have an odd number of negatives in that, so that makes it overall negative, which tells me it's going to be below. So I can actually come in here on the graph. Between -4 and -2, my graph will be below. Let's continue. So 1.5. So we don't need to check these two, but we got to plug it in here. So -1.5 and -3 is a negative. -1.5 and 4 is positive. -1.5 and 2. That one you might have to think about when you get real close. -1.5 and +2 is going to leave you with a positive. So we have two negative symbols here, which means overall, since that's even, that'll be positive. And our graph should be above. So that means it's going to go like this. Kind of as expected so far. Plug in our 0. So 0 minus 3 is negative. 0 plus 4 is positive. And 0 plus 2 is also positive. So that means, let's read this, be careful, because this is where you don't want to jump to conclusions yet. Two negatives, that's even, so that means overall we're going to be positive, and it says my graph should be where? Above. So that means when I go down to my sketch, is my graph going to go down here? No, it's got to go, I'm doing my best to kind of, it bounces before it connects. And you can plug this into Desmos and you can see this thing touch the x-axis. It's almost like a bouncy ball. It hit the ground and it bounced straight back up. And there's something special going on at that 0 that makes that happen. And I'm not going to quite tell you yet. I want you to kind of lead into it. And I'll probably send you that note probably Friday to make sure everybody's there. All right, let's check our last one. Let's plug in our 6. So 6 minus 3 is positive. Keep my color scheme right. 6 minus 3 is positive. 6 plus 4 is definitely positive. And 6 plus 2 is positive. So we've got one negative, which means it should be negative, and it should be below. So that one checked. And this is what our graph looks like. And I'm going to put, since I had to count this out, I should have done it on the last one. I'm going to put labels above this. Because if I were to have you submit one of these like I do with your graph, I don't want you to label the y-axis because I'm not worried about finding those values yet. I just want you to label the x-axis about where it's going through, where it's bouncing, and in each range, okay?